welcome to Pankti's tutorial. This video lecture would be about how we can find out the response of a discrete time LTI system for any discrete time input when the impulse response of the system is known to us. So here what I am saying is we know the impulse response of the system, which I have denoted here as h of n. Now the system that I have taken is system which I have named as S1. Now to this system, when the impulse signal is given as the input, the response that we are getting is h of n, which is denoting the impulse response of the system. Now to the same system S1, I am giving some other discrete time function as the input. So now my input is f of n, and for this input, I want to find out how this system will respond using this impulse response. To solve this kind of a problem, the procedure that I will be adopting will be when I know how to represent this discrete time signal as a function of time shifted impulse signal. This I have discussed with you earlier, and the link of that I have provided in the description part. So let us now try solving this problem using that method. So here we are given an LTI system. So the system that we are given is an LTI system. This system, when it takes del of n as input, it produces h of n as output, and the h of n that we are given in the question is this. So this is equal to 3,5 and the arrow is at 3. Now to the same system, if I am giving input as f of n, which is given in the question as 1,4, so f of n is equal to 1,4 and the arrow is at 1. I need to find out how this system would respond to this input, and in that case I am naming the response as y of n. So for this input, the response is y of n, and with these two things I need to find out y of n. So f of n, which is 1,4 in the form of time shifted impulse signal, can be written as f of n equal to del of n plus 4 times del of n minus 1, because the weight at n is equal to 1 is 4, that is why it is 4 here, and the weight at n is equal to 0 is 1, so it is just 1 here, or there is no multiplication factor that is needed. Now to the system that we have considered, which is LTI system. LTI stands for linear time invariant system. Now to this system, when I am giving del of n as the input, I am getting h of n as the output. Now to the same system, when I give del of n minus 1 as the input, the output that I should get should also be shifted by the same amount of time, because it is a time invariant system. In LTI, this Ti stands for time invariant system. And also when I multiply this with 4, the output should also get multiplied with 4, because the system is an LTI system and it satisfies the property of linearity, which composes of superposition principle and homogeneity principle. So homogeneity principle means when at the input side I am multiplying the input with a constant, the output also gets multiplied with the same constant. Now when I am summing the inputs, the output should also get summed, because this is one part of the linearity principle, and that is superposition. So using this form, this actually represents the function f of n. So this sum of the output should represent the function which is y of n. And let us now evaluate y of n from this summation. So to do the summation of this h of n plus 4 of h of n minus 1, let's substitute the values. We know h of n is equal to 3,5 because it is given in the question, and we have the arrow at 3, which is representing the value at n is equal to 0 time instant. The next thing that we have is h of n minus 1. So here what we are doing to obtain h of n minus 1, we are providing a time shift to the right by 1 time instant. So when I am providing a right shift by 1 time instant, this 3 would move at n is equal to 1 position, and this 5 would move at n is equal to 2 position. So we will not be left with any value at n is equal to 0 time instant. So for that I am putting a 0 here, because we need to put that arrow for n is equal to 0 time instant. Now here the weightage with which this is multiplied is 4. So I'll have 4 h of n minus 1, which is then equal to each time instant value multiplied with 4. So this will be 0, 12, 20. Next thing I need to do is, to get y of n, I need to add hn plus 4 hn minus 1. So when I am adding this, it will be 3, 5 plus 0, 12, 20. Now for this addition, what will happen is, the values that are present at the same time instant will get added. So the values at n is equal to 0 are 3 and 0. So there will be 3. The value at n is equal to 1 is 5 and 12. So 12 plus 5 will be 17. And the value at n is equal to 2 time instant will be only 20. So the result that we have is y of n is equal to 3, 17, 20. And the arrow will be at 3, representing the value at n is equal to 0 time instant. So this is how we can find out the response of a discrete time, linear time invariant system for any input discrete signal when we know the impulse response of that system. Let us now summarize the analysis that we have done so far in a generalized manner. So what we have here is this equation. Now in this equation, this 4 is representing the value of f of n at n is equal to 1 time instant. So this is the value at n is equal to 1 time instant, and here also this 4 is the value at n is equal to 1 time instant. Therefore, what I can write here is, when I take the instant to be k, this complete equation can be written as this, where f of k multiplied with del of n minus k through the system gives f of k multiplied with h of n minus k. Now this equation, when I apply the summation onto this equation, it will be transformed to summation for k is equal to minus infinity to plus infinity, f of k del of n minus k. When it passes through the system, it is again resulting into summation from k is equal to minus infinity to infinity, f of k h of n minus k. Now the same summation that we had put at the input side is going at the output side in the same manner, because the system is a linear system. Now this can be written as f of n convolution del of n. So here I am introducing a new function to you, and that function is this convolution function. Now what this convolution function is doing is, when I am convolving f of n with del of n, the signal that I get is actually f of n. So del of n is an identity signal for convolution. That means any signal when it is convolved with del of n, it will result into the same signal, it will not change. But when you look at the output side of the system, this gives us the input signal convolved with the impulse response of the signal, and this then produces the output signal that we want, which is y of n. So for a discrete time LTI system, we can find out how this system would respond to any discrete time input signal in the form of f of n when we know the impulse response of this system, and that is done by finding out the convolution between f of n and h of n, which will give us a resultant function or the response of this system for the signal f of n, which we are taking as y of n. And convolution is performed in a similar manner what we have done here. To understand convolution in a better manner, we'll see some more numericals in the coming videos. Thank you for watching it.